Welcome back to our YouTube channel, Aman. In today's episode, we are going to discuss about Bitwise Complement Operator. By using this symbol, we are going to use Bitwise Complement Operator. So this symbol is considered as negation symbol. So let's see the syntax. So negation value. The execution process of Bitwise operator is that to invert the bits. So whenever we do this thing, negation value, then it is going to perform literal complement operator. Inverting the bits is nothing but 1 becomes 0 and 0 becomes 1, right? So this 1 becomes 0 and 0 becomes 1 is known as inverting the bits. So the formula of bitwise complement operator is that the negation value is equals to minus of value plus 1. So wherever we do this negation value, so internally it is going to done like this. Minus of value plus 1. This is a formula for bitwise complement operator. So before seeing this practical, we are going to see some important note points. See here. In computer science, all negative numbers are going to stored in main memory in the form of 2's complement of any number. So in computer, if we want to store a negative number, then it is going to stored in main memory in the form of 2's complements of that number only. So here 2's complement of a number is equals to 1's complement of a number plus 1. So this is a formula for 2's complements. So the 1's complement is nothing but 1's becomes 0 and 0's becomes 1. That is 1's complement, right? So if you try to understand the binary addition rule, so see here, 0 plus 0, the output is 0, right? So 0 plus 1 is going to be 1. 1 plus 0 is also going to be 1. But 1 plus 1, see here, in 8421, so in order to represent 2, we are going to keep here 1 and remaining all are 0, right? So this is a binary equivalent of 2. So here we have to represent in the form of zeros and ones only, right? Not in the form of decimal number system. Because it is a binary addition rule. In the place of 2, we are going to consider this 2. 1 and 0. Here we are going to do like this. 0 with carry 1, right? So first of all, we are going to use 0. From left side, we are going to take, right? So 0, this is a carry element that is going to take 1, right? So that is the reason we are going to take here 0 with carry 1 in the place of 1 plus 1 in binary addition. So this is the main important note points in this bitwise complement operator. So let's see the practical examples of bitwise complement operator, which is most important. Now I'm opening Python command prompt. See here. So this is my Python command prompt. Now I'm going to declare like this. See here. A is equals to 10 I'm going to declare. And I'm going to use negation A or tilted A. Before going to execute that negation A, I'm going to do this thing. See, the formula of bitwise complement operator is negation value is equals to minus of value plus 1. Here the value is 10, right? They are considered a negation of 10. So whenever it is going to do negation of 10, the formula is like this. So minus of value plus 1, right? So minus of value plus 1 is equals to minus 10 minus 1. Minus into plus minus, right? So the answer is going to be minus 11, right? It is going to print here. So let's see, is this right or wrong? See, the output we have minus 11, right? So this is a negative number, right? So minus 11 is a negative number. So the note we have all negative numbers stored in the main memory in the form of 2 complements of a number, right? So see here, I'm going to do, this is negation of 10, right? We are done. So I'm going to do negation of 10 is equals to minus 11 or not. See here, and so understand this thing. So I'm going to prove that is this negation of 10 is equals to minus 1 or not. So why in the sense? See here, when we are use this negation of A, it is going to consider negation of 10, right? Like this. So when we are executed this negation of 10, the output is going to be minus 11, right? So is this true or not? I'm going to prove it internally. So now negation of 10, right? We are declared here negation of A in the system. So negation of 10, so negation of 10, right? So we have to write the 10 binary format. So binary format of the 10 is 1010, right? So better to take some extra zeros. Okay. So 0, 0, 0, 0 and 1010. This is an binary equivalent of this 10. The execution process is that to invert the bits. Inverting the bits in the sense converting ones to zeros and zeros to ones, right? So this ones to zeros and zeros to ones is also known as ones complement, right? So see here, ones complement is nothing but 1 becomes 0 and 0 becomes 1. Now I'm going to invert this bits. See, inverting this bits. So 0 becomes 1, 1 becomes 0. And here also 0 becomes 1, 1 becomes 0. Here all zeros, we are going to do all ones. So this is bitwise complement operator value, right? What we get the answer? We get the answer as minus 11, right? So we got this answer as minus 11. So we are going to take this. So we are going to take the counter opposite of minus 11. That is plus 11, right? So now consider this plus 11 and I'm going to convert this plus 11 into binary format. So binary format of this 11 is 1011. By if you go to 8421 code, so when we put 1 in the place of 8, when we put 2 in the place of 1, when we put 1 in the place of 1, if I try to add 8 plus 2 plus 1, then the answer is going to be 11. So that is the reason this is a binary format of 11. So I want to convert this 11 into 2's complement. So in order to do a 2's complement of that 11, I want to do first one complement of 11, right? So one's complement in the sense zeros becomes ones, ones becomes zero, right? So here 1 we have 0, 0. Here 0 we have 1. Here 1 we have 0. So the zeros becomes 1. So this is a one's complement of this 11. Now I'm going to add plus 1 to this one's complement of 11. So if I try to add plus 1, the output is going to be, so 2's complement of 11 is going to come, right? So see here, 0 plus 1, the output is going to be 1, right? So remaining all are same, 0, 1, 0, 1, 1, 1 and 1. So what is this? So what is this? This is an 2's complement. So 2's complement of 11, right? So 2's complement of positive 11 is 1, 1, 1, 1, 0, 1, 0, 1, right? When we do negation here, the output is minus 7, right? So when we invert the bits of minus 11, the output is like this, right? This is an answer for bitwise complement for this negation term. The output we got is minus 11. If we took this minus 11 and we have to take counter opposite of minus 11, that is plus 11. So if we try to convert this plus 11 to its complement, then the 2's complement of this plus 11 is going to be like this, right? So 1, 1, 1, 0, 1, 0, 1. So this is a value of minus 11, right? So if we try to do negation of 10, we got the same result. So if we try to do 2's complement of that 11, we got this same answer. So that is the reason this negation 10 and minus 11 both are equal. Hence proved, right? So same like if we took A is equals to 0 and negation of that A, the output is going to be first calculate. So negation of 0. So minus val minus 1. So value is 0, right? Minus 0 minus 1 is going to be minus 1, right? So try to execute this thing. Minus 1 we got answer, right? So whatever we did in this example. So if we try to do for this example, so then we are going to get like this. Negation of 0 is equals to minus 1. So this is all about bitwise complement operator in Python programming language. So that's all for today's episode. In this episode, we are discussed bitwise complement operator in Python. So which is most important. So that's all for today's episode. I hope you all understand. Don't forget to like, share, and subscribe to Aman Codes. Thank you so much for watching.